Hello there, and welcome to Mysteries Beneath Earth, where we usually dig deep into the soil to find the secrets of the past. Tonight, however, we are going to do something different. We are going to drift forward. We are going to perform a thought experiment that is both terrifying and strangely peaceful. We are going to imagine a world where the noise has stopped, a world where the machinery has wound down, a world where we are gone. Sit comfortably, let your shoulders drop. Listen to the hum of the room around you. Maybe it is the soft whir of a computer fan, the distant rumble of traffic outside your window, the refrigerator cycling on in the kitchen, or the faint, high-pitched whine of electricity moving through the walls. We are so accustomed to this vibration that we barely notice it. It is the heartbeat of our civilization, a constant, rhythmic pulse of energy, movement, and data. But what if it stopped? Not slowly, not over centuries of decline, but suddenly. Imagine that tomorrow the human race simply vanishes. We will not ask how or why. There is no war, no disease, no alien event. Just a sudden, clean subtraction. The people are gone, but the stage remains set. The coffee cups are still warm on the desks. The cars are still rolling on the highways. The power plants are still burning coal and splitting atoms. The satellites are still blinking in the silent vacuum above. The world is exactly as we left it, but the operator has stepped away from the controls. This is the starting point of our journey into deep time. We want to ask a specific question. If we fast forward 10,000 years, a span of time twice as long as all of recorded human history, what would remain? Would a future visitor, landing on this blue sphere, know that we were ever here? Would they find our cities, our books, our plastics? Or would the Earth, in its endless, patient cycles of erosion and growth, have wiped the slate clean? To understand the end, we must look at the beginning. The first few hours after humans vanish would not be silent. In fact, they might be chaotic. The immediate legacy of our disappearance would be the machines trying to make sense of a world without instructions. In power plants across the globe, automated systems would sense a drop in demand. As lights remain on in empty rooms and factories sit idle, the grid would struggle to balance itself. Coal-fired plants, running on automatic feeders, would continue to burn fuel until their piles ran dry or a mechanical error triggered a safety trip. Wind turbines would keep spinning, and solar panels would keep drinking in the sun, feeding voltage into a grid that has no one to manage the load. Within hours, the delicate balance of the electrical grid would fracture. Without human engineers to reroute power or manage the fluctuations, the system would cascade into failure. You can imagine the scene in a place like Times Square or Shibuya Crossing. The giant screens, flashing advertisements for products no one can buy, would flicker. The streetlights, obediently waiting for a dusk that no one will see, would struggle against the surging voltage. And then, one by one, the breakers would trip. The hum would die. The silence that follows is something the Earth has not known for 2 centuries. It is a heavy, absolute silence. No sirens, no honking horns, no distant roar of jet engines tearing the sky. Just the wind, the rustle of leaves, and the sound of the ocean. But in this silence, the clock of decay begins to tick. The countdown to 10,000 years starts now. The first changes are subtle. They happen in the dark. In the tunnels beneath our feet, the subways of London, New York, and Moscow rely on massive pumps to keep the groundwater at bay. These pumps are the unsung heroes of the modern metropolis, fighting a battle against nature every single minute of every single day. Without electricity, the pumps stop. The water, patient and relentless, begins to rise. Within 36 hours, the tunnels are flooded. The underground arteries of our civilization become dark, submerged rivers. The rats and mice, the shadow citizens of our world, scurry upward, confused by the rising tide. On the surface, the climate control systems in our buildings fail. The skyscrapers, those glass needles we drove into the clouds, are sealed environments. They were designed to breathe with the help of fans and chillers. Now they begin to suffocate. The air inside becomes stale. In the summer, the heat builds up, turning glass towers into greenhouses. In the winter, the pipes freeze. And this is where the first physical destruction begins. Water expands when it freezes. It is a simple law of physics, but it is a law that will dismantle our world. Copper pipes hidden behind drywall burst. Fire sprinkler systems shatter. Water sprays into the empty offices, soaking the carpets, the drywall, the desks, and the computers. The cloud, that ethereal place where we stored our memories, our photos, our knowledge, vanishes the moment the servers lose power. The internet is not a ghost. It is a physical thing, dependent on electricity and cooling. When the fans stop, the servers overheat. When the power dies, the data becomes inaccessible. Billions of terabytes of human experience. The videos of our children, the scientific papers, the angry comments, the love letters, are locked away in silent black boxes, waiting for a key that will never turn. This is the beginning. It is a time of ending, but also a time of strange beauty. The stars, long hidden behind the veil of light pollution, would return to the skies above our cities. The Milky Way would arch over the dark silhouette of Manhattan. The aurora borealis would be visible further south, uncompeded by the glow of sodium vapor lamps. The planet, for the first time in ages, would look like itself again. But down here, among the ruins of the everyday, the great unraveling has only just begun. The Earth is about to demonstrate just how temporary our permanent world really is. In the grand scale of 10,000 years, the first week seems insignificant. It is a blink, a breath. But for the machinery we left behind, this first week is the most violent trauma it will ever face. We built our world to run on a constant feed of attention. We are the caretakers of a volatile beast called infrastructure. Without the caretaker, the beast thrashes and dies. The most immediate and dangerous legacy we leave behind is not our plastic or our concrete, but our fire. We have trapped the power of the sun and the power of the atom, and neither of these forces likes to be ignored. Let us look first at the fossil fuel industry. Around the world, there are thousands of oil refineries, chemical plants, and natural gas facilities. These are complex networks of pressure vessels, pipes, and catalytic crackers that operate at extreme temperatures and pressures. They rely on automated safety valves to vent gas if the pressure gets too high. In the first few days, as the power fails and the control rooms sit empty, these safety valves will open. Flares will light up the night sky, burning off excess gas in a final, lonely salute to the industrial age. But eventually, the systems will fail. A pipe will corrode or a valve will stick. A spark from static electricity or a lightning strike will find a pocket of leaked vapor. The result will be a series of explosions that will rock the industrial zones of the world. Enormous fires will burn for weeks, consuming the tanks of fuel we stored for a future that never came. Black smoke will choke the skies, and soot will rain down on the silent suburbs. But these fires are nothing compared to the silent threat waiting in the cooling pools of our nuclear power plants. There are roughly 450 commercial nuclear reactors on Earth. When the grid goes down, these reactors will automatically scram, a procedure where control rods are dropped into the core to stop the fission reaction. This works perfectly. The chain reaction stops, but the fuel rods are still incredibly hot. They generate decay heat and need to be constantly cooled by circulating water. Usually, this water is pushed by electric pumps powered by the grid. When the grid fails, backup diesel generators kick in. These generators are robust. They have enough fuel to run for days, perhaps a week. But eventually, the diesel runs out. The pumps stop. The water in the cores and the spent fuel pools become still. And then, it begins to boil. This is the terrifying phase of the first month. Across the northern hemisphere, from France to Japan, from the United States to Russia, the water in these cooling pools boils away. The fuel rods are exposed to air. The zirconium cladding on the rods reacts with the steam, generating hydrogen. Pressure builds, and then explosions. Not nuclear explosions like a bomb, but steam and hydrogen explosions like we saw in Chernobyl or Fukushima. Radioactive plumes will rise into the atmosphere, carried by the winds. The fallout will settle over the land, creating zones of exclusion that will last for centuries. But interestingly, nature does not fear radiation the way we do. We have seen this in the exclusion zone around Chernobyl. Without humans hunting them or destroying their habitat, animals move back in. Wolves, boars, deer, and even rare horses thrive in the radioactive forests. They live shorter lives, perhaps, and they carry tumors, but the population grows. The absence of humans is a greater boon to them than the presence of radiation is a curse. So, in the first year, we create a ring of radioactive nature reserves around the globe. While the industrial world burns and melts, the domestic world begins a quieter, sadder decline. The pets we left behind face the hardest transition. The dogs and cats locked inside houses have no chance. They will wait for the sound of a car in the driveway that will never come. It is a heartbreaking thought, but it is part of the biological correction that is happening. The pets that are outside, or those that manage to escape, face a world they are not built for. Our modern dogs are masterpieces of genetic engineering, but they are engineered for friendship, not survival. A Chihuahua, a pug, or a bulldog has no place in the wild. They will be the first to fall prey to larger animals, to cold, or to starvation. But the working breeds, the German Shepherds, the Huskies, the Collies, might stand a chance. They will form packs. Instincts buried under thousands of years of domestication will resurface. They will hunt the deer that are beginning to venture into the quiet suburbs. They will raid the supermarkets where the food is rotting on the shelves. However, they will face competition. The true wild animals will notice the silence. Coyotes in North America, foxes in Europe, and jackals in Asia are already adaptable scavengers living on the fringes of our cities. When we leave, they will move to the center. The battle for the ruins of the city will be fought between the packs of feral dogs and the encroaching wild predators. Within a few generations, the specialized breeds of dogs will be gone. The survivors will merge, interbreeding into a generic wolf-like shape, lean, strong, with upright ears and a short coat. The dog as a species will survive, but the breed will vanish. The zoos provide another chaotic element to this first year. Most animals in cages will perish, unable to access food or water. But in some places, fences will break. A falling tree, a rusted lock, or a desperate charge might free them. We might see surreal scenes. A herd of elephants wandering the streets of a silent European city, or lions stalking deer in the overgrown parks of an American metropolis. Most of these exotic escapees will die when the winter comes. A lion cannot survive a snowy winter in New York. But in warmer climates, we might see the establishment of new, invasive populations. Hippos in the rivers of South America, camels in the deserts of the American Southwest. The biological map of the world is being redrawn in real time. And what of the food we left behind? The supermarkets, those temples of abundance, will become tombs of rot. Without refrigeration, the meat and dairy spoil within days, filling the aisles with a stench that attracts the rats and the flies. The vegetables turn to black sludge. But the processed food, the canned goods, the vacuum-sealed snacks, the honey, the dried pasta, these will remain edible for decades. They will sit on the shelves, gathering dust, a hidden treasure for any creature clever enough to open them as the first winter approaches. The silence deepens. The fires in the cities have mostly burned themselves out. The radioactive plumes have settled into the soil. The grid is dead cold. The satellites above, uncorrected by ground control, continue to drift, but their signals are screaming into the void. On the ground, the snow falls on unplowed roads. It piles up against the doors of the silent houses. It weighs down the roofs of the warehouses. The machine, that vast, interconnected system of logistics, energy, and information that we spent 5,000 years building, has completely stopped. It took us millennia to wind it up, but it took only days for it to spin down. The Earth is now alone with the artifacts we created. The era of maintenance is over. The era of entropy has begun. And entropy is a patient, relentless worker. It has all the time in the world to dismantle what we have done, brick by brick, bolt by bolt. In the next stage of our journey, we will move from the immediate shock of the first year into the slow, grinding decay of the first decade. We will watch as the home, the sanctuary of human life, is invaded by the very nature we tried so hard to keep out. We will see what happens when the roof fails, when the water gets in, and when the forest decides to take back the living room. The domestic collapse is coming, and it will be thorough. We now move our gaze from the chaotic industrial fires of the first year to something much more intimate. We move to the suburbs, the villages, and the quiet residential streets where most of humanity actually lived. This is the era of the domestic collapse. It is a period that lasts roughly 20 years, a single generation of neglect that will undo centuries of architectural evolution. When we think of ruins, we often think of stone castles or marble temples, structures that age with a certain dignity. But the modern home is not built like a Greek temple. It is built like a temporary shelter, constructed from materials that are chemically unstable and desperate to return to the earth. The modern house is a skin of vinyl or brick veneer wrapped around a skeleton of soft pine wood, insulated with pink fiberglass and lined with gypsum board paper. It is a machine designed to repel water, but it only works if there is a human constantly patching the armor. The primary enemy of the house is water. Water is the great solvent, the patient destroyer. For the first year or two, the house holds its own. The paint peels a little under the UV radiation of the sun. The vinyl siding might crack in the winter frost, but the defenses hold. The turning point comes with the failure of the roof. The roof is the hat of the house, and like any hat left out in the weather, it eventually fails. Most modern homes use asphalt shingles. These are essentially mats of fiberglass soaked in oil and coated with grit. Under the relentless beating of the sun, the oil evaporates. The shingles become brittle. They curl at the edges. A strong wind, a tail end of a hurricane or a fierce winter gale, comes along and rips a few of them loose. That is the beginning of the end. The first hole in the roof is small, perhaps the size of a dinner plate, but it is enough. The next time it rains, water finds its way onto the plywood sheathing beneath. Plywood is an engineered wood, layers of veneer glued together. When it gets wet, the glue dissolves. The layers delaminate. The wood swells and turns into a sponge. The water drips down into the attic. This is a dark, quiet space, filled with the fluffy pink clouds of fiberglass insulation. The insulation soaks up the water, becoming heavy and sodden, compresses, losing its ability to insulate. But worse, it holds the moisture against the wooden trusses that hold up the roof. Damp wood in a dark, unventilated space is a dinner bell for the fungal kingdom. Mold spores, which are always present in the air, land on the wet wood. They begin to feed. We are talking about dry rot, brown rot, and white rot. These fungi digest the cellulose and lignin that give wood its strength. Slowly, silently, the structural integrity of the roof beams turns to mush. Meanwhile, another invasion is happening at ground level. The gutters, those aluminum troughs we installed to guide water away, are now clogged with the leaves of 20 autumns. They are packed solid with a rich, dark compost. Seeds blown by the wind land in this compost. We have all seen this in abandoned houses, a garden growing in the gutters. Grass, weeds, and even small saplings take root right at the edge of the roof. Because the gutters are clogged, the rainwater overflows. It pours down the side of the house, behind the siding, and pools around the foundation. This is catastrophic. The soil around the house becomes saturated. In the winter, this wet soil freezes and expands, pushing against the concrete foundation walls, cracking them. In the summer, the water seeps into the basement. The basement becomes a dark, subterranean swimming pool. The cardboard boxes of old family photos, the stored winter clothes, the holiday decorations, they all dissolve into a pulp. The smell of the house changes. It loses the scent of laundry detergent and cooking, replaced by the heavy, earthy musk of wet rot and mold. Inside the living spaces, the collapse happens from the inside out. The drywall, sheets of gypsum plaster sandwiched between paper, is particularly vulnerable. As water leaks from the attic, it runs down the inside of the walls. The drywall swells, softens, and eventually collapses under its own weight. Ceilings sag and burst, dumping wet insulation onto the living room floor. This damp environment is a paradise for insects. Termites and carpenter ants, the unseen demolition crews of nature, move in. They have been waiting for this. The chemically treated wood of the foundation sill plate might resist them for a while, but the water washes those chemicals away. The termites build their mud tubes up the walls, eating the house skeleton from the inside. You wouldn't hear it if you stood in the living room, but if you pressed a stethoscope to the wall, you would hear the faint, rhythmic munching of millions of jaws. By year 10, the house is no longer a sealed environment. The windows, with their rubber seals dried out and cracked, have allowed rain to blow in. The floors, hardwood or carpet, are buckling. Sunlight streams in through the holes in the roof, bleaching the rectangles on the walls where pictures once hung. And then the wildlife moves in. A broken window or a rotted door frame is an invitation. Raccoons are often the first squatters. They are intelligent, dexterous, and adaptable. They climb into the attics, tearing up the insulation to make warm nests. Squirrels follow. In the chimney, birds build nests, blocking the flue. The house becomes a complex ecosystem. The attic is a nursery for mammals. The basement is a wetland for amphibians and insects. The living room is a highway for rodents. By year 20, the structural failure becomes critical. The roof trusses, eaten by fungus and ants, can no longer support the weight of the shingles, especially under a heavy snow load. One winter night, with a groan that echoes through the empty neighborhood, the roof collapses. It falls into the second floor, and often the momentum carries it through to the first floor. The house has been gutted by gravity. Now it is open to the sky. Sunlight falls directly onto the staircase. Rain washes over the sofa. This accelerates the decay exponentially. The house is no longer a building. It is a pile of resources. The wood decomposes into humus. The glass shards sparkle in the weeds. The plastic siding, incredibly durable, falls off and lies in the dirt, destined to be buried under the rising tide of vegetation. The lawn, that manicured square of green we fought so hard to maintain, has long since vanished. In the first 5 years, the grass grew tall, went to seed, and was invaded by aggressive weeds. Dandelions, thistles, brambles. By year 20, the ecological succession is well underway. Pioneer trees, birch, aspen, or pine, depending on the climate, are pushing up through the remains of the driveway. Their roots are powerful hydraulic jacks, lifting the asphalt, breaking the concrete. The illusion of the yard is gone. The forest has simply stepped forward to reclaim the space that I end just 2 decades. The suburban dream has been dismantled. What remains are chimney stacks standing like tombstones, surrounded by mounds of debris that are slowly turning into soil. But while the wood and brick of the suburbs are surrendering to the earth, the great titans of the city are facing a different, slower, and more spectacular death. Leaving the rotting suburbs behind, we travel to the city center. Here, the timeline of decay moves slower, but the scale is grander. The skyscrapers, the cathedrals of commerce, face a lonely century. These structures were the pinnacle of human engineering, designed to resist gravity and wind, but they were never designed to be abandoned. A skyscraper is a machine. It is a living organism of pumps, fans, elevators, and sensors. When the power died in that first week, the organism died. Now, it is just a skeleton of steel and concrete wrapped in a skin of glass. And it is the skin that fails first. The curtain wall, the outer facade of a modern tower, is made of glass panes held in place by aluminum frames and sealed with silicone or rubber gaskets. These gaskets are the Achilles heel of the skyscraper. They are organic polymers, Under the ultraviolet radiation of the sun and the freeze-thaw cycles of the seasons, they lose their elasticity. They dry out, shrink, and crack. Around year 20 or 30, the seals begin to fail. A pane of glass, weighing hundreds of pounds, slips from its frame. It falls. The sound of a single pane of glass shattering on the street below is startlingly loud in the silent city. It is the starting gun for the rain of glass. As the years pass, this happens more and more. The streets below become treacherous fields of jagged shards. With the skin breached, the wind enters the tower. A skyscraper is essentially a vertical wind tunnel. Without windows, the air pressure differentials between the bottom and the top create powerful drafts. The wind howls through the empty offices, scattering papers that have sat undisturbed for decades, blowing the dust off the rotting desks. It strips the ceiling tiles, sending them swirling out into the void. But the wind also brings life. Seeds, carried on the breeze, float into the broken windows of the 50th floor. They land in the plush, rotting carpets which are now soaked with rain. This is the birth of the vertical ecosystem. It is a strange, suspended nature. We might see moss growing on the north side of executive desks. We might see tough, wind-resistant grasses taking root in the elevator lobbies. The most successful residents of the high-rise canyons are the birds. Peregrine falcons, which we once reintroduced to cities to control pigeon populations, are perfectly adapted to this environment. To them, a skyscraper is just a cliff. Now, without the annoyance of window washers or flashing lights, they claim the towers as their exclusive domain. Their nests dot the broken ledges of the 80th floors. They hunt the pigeons and crows that roost in the lower levels. The city becomes a massive, artificial mountain range, teeming with avian life. However, deep inside the structure, a silent chemical war is being waged. The enemy is rust. The skeleton of a skyscraper is steel, beams and columns that give it strength. In modern construction, this steel is often encased in concrete or sprayed with fireproofing material. But water is patient. As rain blows in through the broken windows, it seeps into the floors. It finds the microscopic cracks in the concrete. When water reaches the steel rebar inside the concrete, it causes the steel to rust. Rust iron oxide takes up more space than the original iron. As the steel expands, it pushes against the concrete from the inside. This pressure is immense, causes the concrete to spall, to crack and flake off in chunks. If you were walking on the street below in year 50, you would need to be very careful. Not only is glass falling, but chunks of concrete the size of engine blocks are periodically detaching from the sides of buildings and plummeting to the earth. The bolts and rivets that hold the steel frame together are also corroding. But skyscrapers are over-engineered. They have redundancy built in. A few rusted bolts won't bring a tower down. It will take centuries for the main frames to fail. So, for this first century, the skyline remains largely intact. The silhouette of the city is familiar, but the details are horrifying. The towers are tattered, gap-toothed giants, whistling in the wind at the street level. The environment has transformed completely. The canyons between the buildings are shadowed and cool. The drainage systems, the sewers and storm drains, blocked up decades ago. The streets are no longer paved roads. They are riverbeds. Every time it rains, water rushes down the avenues, carrying silt and debris. This sediment settles over the asphalt, creating a layer of soil, and this new soil, the urban forest, takes hold. But it is not a forest of oak or maple. It is a forest of the toughest, most aggressive survivors. The Ailanthus altissima, also known as the Tree of Heaven, is the king of the ruins. It is an invasive species from China that can grow in pure concrete. Its roots release toxins that kill rival plants. In the 1st century, these trees erupt from the sidewalks, their roots heaving up the pavement slabs. They grow fast and die young, creating a cycle of rapid biomass accumulation. Alongside them, we find the buttelja, the butterfly bush, colonizing the crumbling brickwork. Vines like kudzu in the south or English ivy in the north act as green shrouds. They climb the sides of the buildings, finding purchase in the cracked masonry. These vines are heavy. Their weight pulls at the facades. A brick wall, weakened by rain, can be pulled down simply by the weight of the ivy clinging to it. The animals of the street level are cautious. The streets are dangerous places. Falling debris is a constant hazard. Predators like coyotes, wolves, and eventually bears learn to navigate this maze. They use the subway entrances as dens, cool in the summer and sheltered in the winter. The subway tunnels themselves are fully flooded, dark subterranean lakes where perhaps blind, albino populations of fish or crustaceans are beginning to evolve in isolation. Cut off from the surface world, by the time we reach year 100, the city is unrecognizable to a modern eye. It looks like a ruin from an ancient civilization, though it is only a century old. The glass is mostly gone. The streets are green valleys. The silence is profound, broken only by the wind, the call of the falcons, and the occasional thunderous crash of a concrete panel hitting the ground. But the most dramatic event of this era is not the slow decay of the buildings. It is the fire. Without a fire department, a lightning strike on a dry summer day can turn a city into an inferno. In the managed world, we stopped fires. In the wild world, fire is a cleansing agent. A skyscraper, with its broken windows creating a chimney effect and its floors filled with dried-out carpets and paper, is a perfect torch. We might see the spectacle of a towering inferno burning for days, unchecked. The heat from such a fire weakens the steel frame. The metal softens, and then the structure fails. The collapse of a skyscraper caused by fire is a terrifying event. A vertical implosion that sends a dust cloud rolling through the overgrown streets. These burnt-out carcasses, twisted piles of steel and fused glass, become the first true geological formations of the new era. As we cross the threshold of the 1st century, the superficial decay is complete. The paint is gone, the glass is shattered, the wood is rotted. Now, the planet begins to attack the bones of our civilization. The great bridges, the dams, and the monuments are next. The era of the Great Toppling is about to begin, where the icons of human history will fall one by one into the rising waters and the deepening soil. We are now deep into the silence. A century has passed since the last human voice spoke. The cities are green canyons, the suburbs are young forests, and the sky is clearer than it has been for millennia. But the world is about to change again. We are entering the era of the Great Toppling. This is the time when gravity finally wins its long war against engineering. For the last 100 years, the great suspension bridges of the world, the Golden Gate in San Francisco, the Verrazzano in New York, the Akashi Kaikyo in Japan, have stood defiant. They are masterpieces of tension, holding thousands of tons of steel road deck in the air using cables spun from smaller wires. But tension is nothing more than stored energy waiting to be released. And the lock that holds that energy in place is metal. The primary enemy here is salt. In coastal cities, the air is filled with a fine mist of saline spray. For a century, this salt has been settling on the main cables of the bridges. In the time of humans, these bridges were painted and inspected constantly. Men hung from ropes, chipping away rust and applying new coats of protective zinc and epoxy. But the painting stopped long ago. The salt eats through the paint, defines the steel wires underneath. A suspension cable is made of thousands of individual strands bundled together. As the outer strands rust, they snap. Each snap is a small event, a sharp, metallic ping that might be heard by a seagull perched on the tower. But over decades, these snaps accumulate. The cable gets weaker. The load remains the same. Sometime in this window, perhaps year 150, perhaps year 200, the tipping point arrives. It will likely happen during a storm. The wind is howling, putting extra stress on the structure. The temperature drops, causing the metal to shrink and pull tighter. And then, with a sound like a thunderclap that can be heard for miles, the main cable gives way. The release of energy is terrifying. The cable whips back, slicing through the air faster than the eye can follow. The road deck, suddenly unsupported, twists. It ripples like a ribbon in the wind before tearing apart. Thousands of tons of concrete and asphalt crash into the water below. The splash sends a tsunami washing over the ruined shorelines. When the spray settles, the towers still stand, lonely stone or steel sentinels, but the span is gone. The connection is broken. The islands are isolated once again. This scene plays out across the globe. The Brooklyn Bridge, with its stone towers, might last longer than the steel giants, but its wooden walkway rotted away decades ago, and its cables will eventually succumb to the same fate. The bridges are the first casualties of the Great Toppling because they live under the highest stress. But the monuments are next. Consider the Eiffel Tower. It is made of puddle iron, a material that is relatively pure but still vulnerable. The tower relies on 2.5 million rivets to hold it together. As rust creeps into the joints, it expands. This is a powerful force called oxide jacking. The rust pushes the plates apart. The rivets pop, shearing off their heads. The tower sits on 4 massive legs. As the iron corrodes, the legs weaken. The structure begins to list. It might lean for decades, a leaning tower of Paris, becoming a strange, sad silhouette against the sunset. But eventually, a winter storm will push it too far. The iron, brittle with age and cold, will snap. The great lady of Paris will fold onto herself, crashing into the forest that was once the Champ de Mars in New York Harbor. The Statue of Liberty faces a unique chemical problem. She is a copper skin draped over an iron skeleton. Copper and iron are chemically different. When they are in contact and wet, especially with salt water, they create a battery. This is called galvanic corrosion. The electrons flow from the iron to the copper, causing the iron to rust at an accelerated rate. Gustave Eiffel, who designed the internal frame, knew this. He separated the metals with asbestos soaked in shellac. But that insulation has long since disintegrated. The statue is eating herself from the inside. The iron armature swells. The rivets pop. The copper plates, turned a beautiful verdant green by oxidation, begin to fall off. First a finger, then a ray from the crown. Finally, the arm holding the torch, weakened at the shoulder, breaks away and tumbles into the harbor. She becomes a Venus de Milo of the Hudson, armless and decaying, watching over a dead city on the ground. The buildings are experiencing concrete cancer. Concrete is an artificial rock, a mix of cement, sand, and gravel. It is strong under compression, being pushed down, but weak under tension, being pulled apart. To fix this, we put steel rebar inside it. But concrete is porous. Over centuries, carbon dioxide from the air seeps into the concrete. This process, called carbonation, lowers the pH of the concrete, making it acidic. When the acidity reaches the rebar, the steel rusts. As we know, rust expands. The face of the building begins to flake off. The balconies are the first to go. They shear off the sides of apartment towers, crashing onto the rubble below. The corners of buildings crumble. The great concrete dams, the highways, the stadiums, they are all suffering from this cancer. By year 300, the skyline has changed its teeth. The glass is gone. The sharp edges are rounded by crumbling concrete. The bridges are down. The great icons have fallen or are disfigured. The city looks less like a ruin and more like a geological formation, a series of mesas and cliffs made of rusting steel and rotting stone. The human shape of the world is being smoothed out. But while gravity pulls the structures down, the water is rising up to meet them. The drainage systems have failed completely. The era of dry land in our artificial environments is over. We are moving into the wet, silent phase of history. As we cross the 300-year mark, the geography of the world begins to shift. Not because the continents are moving, that takes millions of years, but because the artificial barriers we built to hold back the water have dissolved. We lived in a world of managed hydrology. We dammed rivers, drained swamps, and built levees. We forced water to go where we wanted it. Now, the water is going back to where it belongs. The most catastrophic failures happen at the dams. There are tens of thousands of large dams across the planet. Some, like the Hoover Dam, are massive wedges of concrete that rely on gravity. They are incredibly durable. The Hoover Dam might actually block the Colorado River for thousands of years, although its intake towers will clog with silt, and the water will eventually spill over the top, cascading down the face of the dam in a spectacular eternal waterfall. But most dams are not like Hoover. They are earthen embankments or thinner concrete arches. Without maintenance, the spillways, the drains designed to handle overflow, get clogged with floating logs and debris. The water level in the reservoir rises behind the dam. It eventually flows over the top of the earthen wall. Water moving over dirt cuts a channel. This channel grows deeper and wider within hours. This is called overtopping. When an earthen dam fails, it doesn't crack. It washes away. The entire structure dissolves into a wave of mud and water. A sudden, massive flood rushes downstream. It scours the river valley, erasing the ruins of towns, bridges, and roads that stood in its path. It buries the valley floor in meters of fresh sediment. The river, freed from its cage, runs wild again. It carves new paths, meandering across the landscape, creating oxbow lakes and wetlands where farmland used to be. This return to the wild is visible in every major delta. New Orleans, Rotterdam, Bangkok, Dhaka. These cities were built on land that wanted to be underwater. They survived only because of electric pumps and massive levees. We saw in the introduction that the pumps failed early. Now the levees wash away. New Orleans disappears almost entirely. The Mississippi River, no longer constrained, changes its course, seeking a steeper path to the Gulf of Mexico. It might swing west, consuming the Atchafalaya Basin. The ruins of the French Quarter become a submerged reef, the tops of the brick buildings poking out of the bayou like navigational hazards. The city is no longer a place. It is a memory buried under mud and water, inhabited by alligators and catfish. London faces a similar fate. The Thames Barrier, that silver line of defense against the North Sea, has been stuck in the open or closed position for centuries. Mechanical failure and corrosion have frozen the gears. If it is stuck open, the tides rush in twice a day. London returns to being a marsh. The Houses of Parliament stand in a swamp. The lower floors are filled with tidal sludge. If it is stuck closed, the river backs up behind it, drowning the city from the inside. Either way, the liquid history of the Thames swallows the capital that I am, New York. The subways have been full for centuries, but now the water rises higher. Manhattan was once a hilly island of streams and ponds before we flattened it. The water remembers. The ancient streams resurface. The streets become canals. The foundations of the skyscrapers, soaked in salt water for centuries, are rotting. Some of the towers lean. Others collapse into the soup of the streets. This era, the drowning world, brings a profound silence to the ruins. Water is a dampener of sound. A city that is half submerged is a quiet place. The waves lap against the glassless windows of the third floor. Barnacles grow on the steel beams of the lobby. Seaweed drifts through the corridors of the bank vaults. This submergence is actually a form of preservation. While the buildings above the waterline are crumbling under the assault of wind and freeze-thaw cycles, the parts underwater are protected from oxygen. Oxygen is the fuel of corrosion. In the hypoxic mud at the bottom of the flooded streets, artifacts are preserved. A plastic chair, a rubber tire, a ceramic mug. If they sink into the silt, they stop aging. They are being packed away into the geological record. The drowning extends to the underground networks. The mines of the world, the deep gold mines of South Africa, the coal mines of Appalachia, the salt mines of Europe, all flood. The water mixes with the minerals exposed by our digging. It becomes acidic, laden with heavy metals. This toxic brew sits in the dark, deep below the surface, a poisonous legacy that will linger for thousands of years. BY year 500, the map of the coastline has changed. Not because of sea level rise, though that is happening too, due to the long lag of climate change, but because the reclaimed land has been lost. The airports built on artificial islands like Kansai in Japan or Hong Kong International are sinking. The sea walls break and the runways become reefs. The ocean takes back what we borrowed. The world is now a place of swamps, bogs, and wetlands. The sharp lines of our geography are blurred. The distinction between land and water is less clear. The ruins of our civilization are slipping beneath the surface, being buried in the soft embrace of sediment. This is the beginning of fossilization. We are no longer the masters of the earth. We are becoming its geology. But even as the physical structures dissolve, something else remains. A shadow, a chemical ghost that we breathed into the atmosphere and poured into the soil. As the physical ruins fade, the invisible legacy of the industrial age becomes the primary marker of our existence. The next 1,000 years will be defined not by what we built, but by what we burned. We have watched the lights go out, the houses rot, the skyscrapers shatter, and the cities drown. By the time we reach the 500-year mark, the surface of the Earth has changed profoundly. The sharp angles of human geometry have been softened by moss and mud. The loud, visible scars of our civilization are healing. But if you were a scientist visiting this future Earth, looking not with your eyes but with your instruments, you would see that the ghost of humanity is still screaming. We are now entering the era of the chemical shadow. This is the period where our legacy shifts from the physical to the molecular. While stone and steel crumble, atoms are forever, and we have rearranged the atomic structure of the planet in ways that will last far longer than our monuments. The most pervasive ghost we leave behind is invisible, odorless, and tasteless: carbon dioxide. For 2 centuries, we dug up sunlight that had been buried for millions of years in the form of coal and oil, and released it back into the atmosphere in a geological blink of an eye. When the machines stopped in year 0, the emissions stopped. But the atmosphere does not reset instantly. 500 years later, the carbon pulse is still lingering. The Earth has natural mechanisms to scrub carbon from the air. Forests breathe it in, oceans absorb it, rocks weather and bind it. But these processes are slow. In this future world, the concentration of CO2 is still significantly higher than it was before the Industrial Revolution. The planet is warmer. The ice sheets in Greenland and Antarctica, which react slowly to temperature changes, are still melting, driven by the heat we locked into the system centuries ago. The sea level is still rising, inch by inch, swallowing the remaining coastal ruins. This invisible blanket of gas has a partner in crime: ocean acidification. The oceans are the planet's great sponge, absorbing about 1/4 of the carbon dioxide we emitted. But when CO2 dissolves in water, it forms carbonic acid. In our timeline, we saw the beginnings of this: bleached coral reefs, thinning shells of microscopic plankton. In the year 800, the oceans are still recovering from this acid bath. The coral reefs, the rainforests of the sea, have largely dissolved. Their calcium carbonate skeletons could not maintain themselves in the acidic water. In their place, we might see vast forests of seaweed and algae, slime-dominated ecosystems that thrive in these conditions. The ocean is alive, certainly, but it is different. It is a simpler, harder world. The delicate, colorful biodiversity of the Holocene reefs is gone, replaced by a murky, resilient Anthropocene marine life on land. The soil tells a different toxic story. Industrial civilization had a voracious appetite for heavy metals. We dug up lead, mercury, cadmium, and chromium. We used them in batteries, paints, pipes, and electronics. When our cities collapsed and burned, these metals didn't disappear. Elements cannot be destroyed. They can only be moved. Around the ruins of major industrial centers, the Ruhr Valley in Germany, the Rust Belt in America, the Pearl River Delta in China, the soil carries a heavy metal halo. If you were to analyze a sample of dirt from what was once a factory floor, you would find concentrations of lead 100 times higher than the natural background. This creates dead zones where plants struggle to grow. But nature is inventive. Over 1,000 years, certain plants evolved to cope. We know of hyperaccumulators, plants like alpine pennycress or certain ferns, that can suck up heavy metals from the soil and store them in their leaves. In this future, we might imagine fields of strange, stunted vegetation growing on the sites of old electronics dumps. These plants are toxic to eat. A deer that grazes here might sicken and die, its bones carrying the lead legacy of a 1,000-year-old battery. Then there are the forever chemicals, the PFAS, the synthetic compounds we used in nonstick pans and firefighting foams. These molecules possess a bond between carbon and fluorine that is one of the strongest in organic chemistry. Nature has no enzyme to break this bond. Bacteria don't know how to eat it. So, these chemicals sit in the water table, moving slowly through the aquifers, unchanging. In the year 1000, a drop of water in a remote underground cave might still carry a trace of a Teflon pan manufactured in 2020. It is a molecular signature that says, "Someone was here who knew chemistry better than they knew caution." But perhaps the most distinct marker of our time is the nuclear layer. In the mid-20th century, humanity detonated over 2,000 nuclear weapons in atmospheric tests. This released a cloud of radioactive isotopes: cesium-137, strontium-90, plutonium-239, that circled the globe and settled everywhere. It is in the ice of Antarctica, the mud of the Amazon, and the silt of the deep ocean. By year 1000, the shorter-lived isotopes like cesium have mostly decayed into harmless barium. But plutonium-239 has a half-life of 24,000 years. It is still there. To a future geologist, this layer will be the golden spike, the sharp, undeniable line in the rock that marks the beginning of the human age. Below this line, no plutonium. Above this line, a sudden global dusting of it. It is a signature that cannot be faked and cannot be erased by simple erosion. This chemical shadow creates a paradox. The world looks wild and green. The forests have returned. The air smells of pine and rain, not exhaust. But the chemistry of the planet is fundamentally altered. We have pushed the Earth into a new state. It is not the world of 10,000 years ago returning. It is a new world, a post-human planet with a hotter climate, a more acidic ocean, and a soil enriched with the exotic elements of our industry. As the millennium approaches, year 1000 since the silence, the physical artifacts are mostly gone. Wood has rotted, concrete has shattered, iron has rusted away. The chemical legacy is invisible. So, what is happening to the life that inhabits this altered stage? The animals and plants have had 40 generations to adapt. The era of the domestic collapse is long over. The era of the new wilderness has fully matured. 1,000 years is a long time for biology. It is enough time for a forest to grow, burn down, and grow again 3 times over. It is enough time for a wolf pack to drift genetically into something slightly different. It is enough time for the memory of man to vanish from the instincts of the animal kingdom. We are now in the era of the new wilderness. When we use the word wilderness, we typically imagine a pristine past, a Garden of Eden untouched by human hands. But the wilderness of the year 2000 is not the past returning. It is a novel ecosystem, a remix of nature that has never existed before. The most obvious change is the new Pangea. For 5 centuries, humans moved species around the globe like pieces on a chessboard. We brought Japanese knotweed to England, European rabbits to Australia, African hippos to Colombia, and Burmese pythons to Florida. We dissolved the geological barriers that had separated ecosystems for millions of years. When we vanished, we didn't take these invaders with us. In the first few centuries, there was a brutal biological war. Invasive species exploded in population, unchecked by natural predators. But by year 1000, the war has settled into a truce. Nature hates a vacuum and it hates imbalance. The ecosystems have stabilized, but they are strange hybrids. In the forests of North America, the undergrowth is dominated by Asian shrubs. The birds that nest in them have adapted their beak shapes slightly to eat the alien berries. In Europe, the raccoon, native to North America but introduced for fur farms, is now a standard part of the fauna, competing with badgers and foxes. The native ecosystem is dead. The global ecosystem has taken its place. The landscape itself has changed texture. The roads, the millions of miles of asphalt ribbon are gone. Asphalt is a liquid trapped in a solid. UV rays oxidize the binder, turning it gray and brittle. Freeze-thaw cycles crack it, but the real destroyers are the roots. Dandelions, then bushes, then trees. By year 1500, a highway is just a clearing in the forest, a long straight line where the trees are slightly younger than the surrounding woods. A satellite photo might show these ghost lines. Faint geometric scars running through the continents, but on the ground, you would be walking through a forest. You might kick a mossy lump and find a layer of crumbled aggregate and a streak of fossilized oil, but the road is no longer a path. The animals have changed, too. Evolution is often thought of as slow, but it can be rapid when the pressure is high. The pressure of the Anthropocene was intense. We killed the big things. We killed the slow things. The survivors were the super generalists. The rats, the crows, the cockroaches, the coyotes in this new wilderness. These generalists have radiated. The rats, freed from the sewers and the competition of humans, might grow larger. Without ships to carry them between continents, the rat populations of New York and London begin to diverge genetically. In 10,000 years, they might be distinct species. We might also see the legacy of the tusk. Even before we vanished, elephants in Africa were evolving to be tuskless because poachers were killing the ones with ivory. In this future, that trait might persist. A population of tuskless elephants, safer from the memory of predation, roaming the savannas. And what of the domestic animals? The cows, the sheep, the chickens? Most perished in the first harsh winters. But the pigs are survivors. Feral hogs are incredibly adaptable. They grow hair, they grow tusks, they become aggressive. In the year 2000, vast herds of wild boars, descendants of farm pigs, roam the ruins of the American South and Central Europe. They are the new dominant grazers, the engineers of the forest floor, rooting up the soil and spreading seeds. Then there is the plastic ecology. Plastic does not biodegrade, but it photodegrades. It breaks into smaller and smaller pieces. By year 1500, the soil and the oceans are filled with microplastics. But life finds a way. We are already seeing bacteria evolving enzymes to digest pet plastic. In this future, these bacteria have spread. Imagine a colony of microbes discovering a buried landfill. To them, it is not garbage. It is a massive, energy-rich food source. They feast on the plastic bottles, slowly breaking them down into basic carbon. It is a slow process, but over thousands of years, the plastic waste becomes part of the carbon cycle. There might even be insects, descendants of wax moths or mealworms, that have evolved gut biomes specifically to eat the plastic layer of the Anthropocene. The cities themselves have become urban forests. The canyons of collapsed steel and concrete provide caves, cliffs, and drainage. This is a perfect habitat. In the ruins of a football stadium, now a bowl-shaped swamp, frogs chorus in the twilight. On the rusted skeletons of cranes' eagle's nest, the distinction between city and nature is erased. The city is nature, just a very rocky, metal-rich version of it. This wilderness is quiet, but it is not empty. It is vibrating with life, but it is a life that has forgotten us. We are no longer the protagonists. We are not even the villains. We are just the precursors, the mysterious force that terraformed the planet, left behind a layer of strange rocks and chemicals, and then vanished. As we move past the 2,000-year mark, the biological stabilization is complete. The scars are covered in green, but beneath the roots and the soil, something else is happening. The stone we built with, the concrete, the brick, the granite, is undergoing its own geological journey. The era of the stone survivors is approaching, where we will see which of our monuments can truly stand the test of deep time, and which were nothing more than sand castles waiting for the tide. As we drift past the 2,000-year mark, the world has settled into a deep, green silence. The forests have finished consuming the cities. The new wilderness is no longer new. It is simply the way things are. The scars of the roads are buried under meters of humus. The jagged skylines of the great metropolises have been smoothed down into rolling hills of rubble covered in vegetation. But amidst this soft, organic takeover, a few hard shapes remain. We are entering the era of the stone survivors. This era is a lesson in material arrogance. For the last 2 centuries of our civilization, we fell in love with concrete. We poured it by the billions of tons. We convinced ourselves that it was artificial stone, a permanent material that would last forever. But geology is cruel to imposters. Concrete is not stone. It is a chemical sponge. As we saw in the earlier centuries, it absorbs moisture and carbon dioxide. It rots from the inside. By the year 3000, almost all modern concrete structures have crumbled. The skyscrapers, the stadiums, the apartment blocks, they have not just fallen. They have dissolved. The cement binder has leached away, leaving behind piles of sand and gravel. A future archaeologist digging into a hill that was once Tokyo or Sao Paulo would find mostly aggregate, loose stones that look natural but are sorted in unnatural ways. However, there are exceptions. True stone, granite, marble, limestone plays by different rules. It does not rot. It only erodes. And erosion is a much slower clock. This means that in the year 4000, the most visible remnants of humanity are not our skyscrapers, but the structures we built in imitation of the ancients. The Great Pyramids of Giza, already ancient when we were building our glass towers, still stand. They are essentially artificial mountains. Their geometry is stable. Gravity has already done its work. There is nowhere left for them to fall. The limestone casing blocks have weathered further, and the sand dunes have drifted high against their flanks, perhaps burying the Sphinx up to its neck once again. But they remain. They are the gold standard of survival, massive, simple, and made of geological materials. Compare this to the Burj Khalifa or the Empire State Building. These were needles of steel and glass. Without maintenance, they were unstable. They fell, they rusted, they vanished. The irony is profound. The older the civilization, the more visible its ruins. The mud brick ziggurats of Babylon dissolved, but the stone temples of Karnak survived. Our civilization, the civilization of steel and plastic, will leave less visual trace on the surface than the Romans or the Egyptians. There is one modern monument, however, that will outlast almost everything else: Mount Rushmore. Carved directly into the granite bedrock of South Dakota, the 4 presidential faces are not buildings. They are geology. Granite erodes at a rate of roughly 1 inch every 10,000 years. In the year 5000, the faces of Washington, Jefferson, Roosevelt, and Lincoln are still crisp. Their noses might be slightly weathered, and lichen might grow in the crevices of their eyes, but they are recognizable to a future visitor. These faces would be the greatest mystery of the New World. For gargantuan heads emerging from a pine forest, staring stoically over a landscape devoid of people. Were they gods? Were they kings? Without written records, which have long since rotted away, there is no way to know. They stand as silent sentinels, the Ozymandias of the American continent. Another survivor is the open pit mine. We moved mountains to get copper, gold, and coal. The Bingham Canyon mine in Utah is a hole nearly 1 kilometer deep and 4 kilometers wide. You cannot erode a hole easily. In 5,000 years, the pumps that kept it dry are long gone. The pit has filled with rainwater and groundwater, becoming a deep, possibly toxic lake. But the shape remains. The terraced sides of the pit, cut with geometric precision, look like an inverted ziggurat. Nature does not make concentric circles like that. It is a negative monument, a scar on the crust that says, "We took something from here." These scars, the Bingham Canyon, the Mir Mine in Siberia, the Chuquicamata in Chile, will be visible from space long after the Great Wall of China has eroded into a soft ridge of rubble. The Hoover Dam, too, might survive in some form. It is a gravity dam, a solid wedge of concrete so massive that even as it chemically degrades, its sheer weight keeps it in place. It has turned into a waterfall, the Colorado River cascading over its rim, wearing a notch into the center. It looks like a natural cliff, but the curvature of its face reveals its artificial origin. Inside, deep in the concrete inspection galleries, the darkness is absolute. The brass railings have turned green, and the generators are rusted hulks, but the plug in the canyon holds to be why the end of this era, around year 5000, the surface world has been effectively scrubbed. If you walk across the site of New York City, you are walking across a hilly woodland. The hills are piles of fallen debris covered in soil. You might find a piece of stainless steel here, a ceramic toilet bowl there. Ceramic is incredibly durable, but the context is gone. The stone survivors stand alone, isolated markers in a world that has moved on. But while the surface is being wiped clean, something fascinating is happening underground. The debris of our lives is being compressed, cooked, and transformed. The city is not disappearing. It is becoming a layer. We are entering the era of the technofossil. We have reached the point where archaeology turns into paleontology. We are no longer looking for ruins. We are looking for fossils. But the fossils of the Anthropocene are not just bones and shells. They are spark plugs, smartphones, tires, and toothbrushes in the deep future. Geological strata usually accumulate slowly. Mud settling on a lake bottom, dust blowing into a desert. But the human stratum is different. It was laid down in a chaotic frenzy of just a few centuries. It is a thin, sharp layer of incredible complexity. The most defining rock of our age is a new type of geological formation, plastoglomerate. We first noticed this in the 21st century on beaches in Hawaii, melted plastic from campfires binding sand, shells, and coral into a hard, rock-like clump. In the year 5000, this process has gone global. When our cities burned in the early years, billions of tons of plastic melted. It flowed like lava down the stairwells of apartment buildings. It pooled in the basements. It mixed with shattered glass, brick dust, and metal scraps. As the millennia passed, this mixture was buried under the rotting vegetation of the new wilderness. The pressure of the overlying soil compressed it. The result is a layer of synthetic rock. A future geologist cracking open a boulder might find a vein of multicolored plastic running through it, preserving the ghost of a bottle cap or the distinct weave of a polyester shirt. It is a fossil, but a fossil of industry, not biology. Consider the fate of the automobile. We built billions of them. In the chaotic end times, highways became parking lots. Millions of cars sat bumper to bumper, rusting in the rain. Over 5,000 years, the iron body of the car oxidizes into a stain of red dust. The leather seats rot. The tires degrade into black sludge. But the car leaves a shadow in the rock. The aluminum engine block oxidizes into a white powder but keeps its shape longer than the steel. The glass windshield, made of safety glass, shatters into thousands of pebbles that form a glittery layer. The platinum and rhodium in the catalytic converter do not corrode. They settle into the soil, creating a concentrated spike of rare earth metals that does not exist in nature. So, the fossil of a traffic jam is not a line of cars. It is a line of chemical anomalies, a stripe of iron oxide mixed with silica, glass, rubber residue, and heavy metals. It is a distinct, unnatural band in the sedimentary record. Technofossils also include things we made of ceramic and glass. Unlike stone, which erodes, high-fired ceramic is nearly eternal. A porcelain toilet, a spark plug insulator, a coffee mug, these things are chemically inert. They are the potsherds of the industrial age. In 10,000 years, a river might cut through a landfill, exposing a wall of perfectly preserved glass bottles and ceramic plates. They will be tumbled by the water, turning into sea glass and smooth pebbles, but they will retain their artificial colors, the bright, unnatural blues, reds, and whites that nature rarely produces in stone. And then there is the urban stratum itself. In geology, we see the KPG boundary, the thin layer of iridium that marks the asteroid impact that killed the dinosaurs. Our boundary layer is thicker but just as distinct. It is a concrete rubble plastic horizon. Below this layer, the fossils are normal: deer, wolves, pollen. Inside this layer, chaos: crushed concrete, high nitrogen levels from our fertilizers, radioactive isotopes from our bombs, and the technofossils of our machines. Above this layer, the new wilderness: wild boars, generalized wolf dogs, and a return to natural pollen counts. This layer is the ultimate answer to the question, will we be remembered? We will be remembered by the earth itself, not as a civilization of poets and dreamers, but as a sudden, violent event that deposited a strange layer of rubble around the globe. We are a geological trauma. Even our bodies contribute to this. The billions of humans buried in cemeteries or lost in the collapse add a spike of phosphate and calcium to this layer. Our coffins, often lined with metal or plastic, add to the preservation. A modern cemetery is, geologically speaking, a very orderly deposit of chemical resources. By the year 7000, this layer is hardening. It is becoming rock. The Anthropocene is no longer a theory. It is a physical stripe in the crust of the planet. But while our trash is becoming geology, there is one legacy that is still active, still dangerous, and still waiting in the dark. We are moving toward the guardians of the waste, the places we tried to mark with warnings that would last for 10,000 years. The era of the guardians is next. We have spent much of this journey looking at things we built to be useful: homes, bridges, cities. But there is one class of structure that we built for a completely different purpose. We did not build them to be used. We built them to be feared. We did not build them for ourselves. We built them for the deep future. These are the nuclear waste repositories, the tombs of the atomic age. And as we approach the 7,500-year mark, they may be the only structures on Earth that still function exactly as intended. The problem of nuclear waste was one of the few times our civilization truly grappled with the concept of 10,000 years. We knew that high-level radioactive waste, spent fuel rods, sludge from weapons programs, contaminated machinery, would remain lethal for millennia. We could not simply bury it in a hole and walk away. We had to ensure that no one, human or otherwise, would dig it up in places like Onkalo in Finland, or the Waste Isolation Pilot Plant, WIPP, in the New Mexico desert. We dug deep into the stable bedrock. We placed the waste in copper canisters, surrounded them with bentonite clay, which swells when wet to seal cracks, and buried them half a kilometer down. Geologically, these tombs are secure. The bedrock has been stable for millions of years. It will likely be stable for millions more. But the danger wasn't the rock. It was curiosity. We worried that a future civilization, having forgotten our history and lost our language, might find these sites. They might see the unnatural geology, the tunnels, the buried metal. They might think they had found a treasure, a tomb of ancient kings, or a mine of rare resources. If they dug, they would unleash an invisible plague. So we tried to design warnings. This field of study, nuclear semiotics, produced some of the most fascinating and disturbing concepts in human history. We asked, how do you communicate danger to a being that does not speak English, does not use the radiation symbol, and perhaps does not even think like a human? By the year 7,500, the surface markers of these repositories have been tested by the elements. In the New Mexico desert, the WIPP site was marked with a design concept called the Landscape of Thorns. It was a proposal to build massive, jagged concrete spikes bursting from the ground, a hostile architecture designed to look menacing, unnatural, and painful. If these were built, they are now weathering. The concrete spikes have been sandblasted by 7 millennia of desert wind. They are rounded, pitted, and cracked, but the shape remains. A field of giant, broken teeth jutting from the scrubland. To a future explorer, this place feels wrong. It does not look like a city ruins, which are rectangular and orderly, or a natural formation, which is fractal and random. It looks like a scar. Other concepts involved menacing earthworks, huge berms of earth shaped like lightning bolts to signify energy and danger. By now, these berms have slumped. They look like strange, undulating hills, but the sheer volume of moved Earth is still visible. It is clearly artificial. The tragedy of the Guardians is that the message has almost certainly been lost. We engraved warnings in the hardest stones we could find: granite, basalt, in all the official languages of the United Nations. English, Spanish, Russian, Chinese, Arabic. We wrote, "This is not a place of honor. No highly esteemed deed is commemorated here. Nothing valued is here. What is here was dangerous and repulsive to us." But languages are living things. They change, evolve, and die. After 7,500 years, English is as dead as Sumerian is to us. The script might be recognizable as writing, but the meaning is opaque. A future explorer might look at the warnings and see religious texts. They might interpret this as not a place of honor, as a ritualistic chant protecting a sacred treasure. The very act of marking the site creates a paradox. A keep out sign is also a look here sign. By building massive monuments to warn the future, we may have guaranteed that the future will investigate. The erosion of the markers adds to the mystery. A broken stone tablet with half a warning is more intriguing than a blank desert. However, there is one warning that does not rely on language. It is the warning of the site itself. If the future explorers dig, they will encounter layers of material that are harder and harder to breach. They will find the reminders: ceramic discs scattered in the soil carrying pictures of faces screaming in pain. If they persist, if they breach the copper canisters, they will face the final guardian: the physics of radiation. Even after 7,500 years, the waste is hot. Those who dig will sicken. Their hair will fall out. Their skin will burn. They will die. This, in a grim way, is the most effective communication of all. The site will become cursed. Legends will grow around it. "Do not go to the land of thorns," the storytellers will say. "The spirits there are angry and invisible." In Finland, the approach was different. At Onkalo, the decision was made to not mark the site at all. Once the repository is full, it will be backfilled with rock. The entrance will be sealed. The landscape will be restored to look like a natural forest. The hope is that by the year 7,500, the forest will have completely masked the entrance. The best guardian is oblivion. If no one knows it is there, no one will dig.so. In this era, we have two legacies. In the deserts of America, crumbling monuments of fear, spikes and berms that whisper of an ancient, poisonous power. And in the forests of Scandinavia, a secret buried so deep that the land itself has forgotten it. Both are attempts to protect the future from our mistakes. Both are bets placed against the curiosity of intelligent life. And only time will tell which bet pays off. While the monuments on the surface are crumbling into dust, there is a layer of human artifacts that remains pristine. To find it, we must leave the atmosphere. We must look up. We are entering the domain of the ring of Earth. When we vanished, there were nearly 8,000 satellites orbiting the Earth. There were space stations, telescopes, and millions of pieces of debris, bolts, paint flecks, booster stages. This was the data sphere that connected our world. But unlike the ruins on the ground, the ruins in space do not face wind, rain, or rust. They face only gravity and the vacuum. The fate of these objects depends entirely on their altitude. The objects in low Earth orbit, LEO, like the International Space Station or the Starlink constellations, are skimming the top of the atmosphere. Even at 400 kilometers up, there are stray molecules of air. These molecules create drag. Without tiny rocket boosts to keep them up, these satellites lose speed. As they lose speed, they drop lower. As they drop lower, the drag increases. Within the first 50 to 100 years after we vanished, the entire contents of low Earth orbit were scrubbed. The International Space Station, a marvel of cooperation, became a fireball. It streaked across the sky one night, burning up in the atmosphere, its molten aluminum raining down into the ocean. The thousands of communication satellites followed it, a century-long fireworks display that no one saw. But higher up, the story is different. At 36,000 kilometers, we find the geostationary orbit, GEO. This is the high ground where we parked our massive weather satellites and communication hubs so they would stay fixed above a single point on Earth. At this altitude, there is effectively no atmospheric drag. A satellite parked here will stay here for millions of years. In the year 8000, the Earth is surrounded by a ring of dead machines. They are silent. Their solar panels are degraded by cosmic radiation, producing no power. Their batteries are frozen blocks of chemicals. Their computers are fried, but physically, they are perfect. The gold foil insulation still glitters in the sunlight. The white paint, though yellowed by UV radiation, is intact. The antennas are still pointed at the silent cities below. If you could go up there and touch one, it would feel like it came off the assembly line yesterday. There is no rust in a vacuum. Over time, these dead satellites drift. The gravitational tug of the moon and the uneven shape of the Earth pull them out of their precise slots. They begin to wander. They cluster at two stable gravitational points, potential wells, over the Indian Ocean and the Eastern Pacific. These become the Sargasso Seas of space, graveyards where the derelict giants of the information age slowly dance around each other. Occasionally, they collide. A collision at orbital speeds is violent. It shatters the satellites into clouds of shrapnel. Over 10,000 years, these collisions create a ring of dust and metal around the equator. It is not a visible ring like Saturn's, but a tenuous halo of silicon, aluminum, and gold. A future astronomer looking at Earth through a telescope might notice this strange anomaly, a planet surrounded by a cloud of artificial glitter. But the most permanent human museum is not in orbit. It is further out. It is on the moon. The moon has no atmosphere, no wind, no water, no tectonic plates. It is a world of absolute stillness. The only force of erosion is the gardening of the surface by micrometeorites, tiny dust grains from space hitting the ground. This process is incredibly slow, turning the topsoil over once every few million years. This means that the 6 Apollo landing sites are essentially frozen in time. In the year 10,000, the descent stages of the lunar modules, the Eagle, the Intrepid, the Falcon, still sit on the gray regolith. They are bleached white by the sun. The American flags, made of nylon, have disintegrated into dust under the UV radiation. But the metal stands. More importantly, the footprints remain. The boot prints of Armstrong, Aldrin, Cernan, and the others are pressed into the dust. They look exactly as they did the moment they were made. The sharp ridges of the sols, the disturbed soil, it is all there. The rover tracks weave between the craters. The scientific instruments, the retroreflectors, the golf balls hit by Alan Shepard, They are all waiting. This is the ultimate irony of our legacy. On the planet where we lived, breathed, and built our empires, almost everything will be erased. Our cities will be mud. Our books will be dust. Our bodies will be soil. But on the dead, silent world of the moon, the evidence of our existence is preserved in high definition. A visitor arriving in our solar system in 10,000 years might look at Earth and see only a lush, wild jungle planet with a few strange chemical scars. But if they look at the moon, they will see the undeniable proof of intelligence. They will see that a bipedal species once walked here, operated machines, and looked back at their home world. The moon is our backup drive. It is the only place where our history is safe from the great eraser of Earth. It is a silent, dusty museum that will remain open long after the civilization that built it has been forgotten. And as we look back down from the moon to the blue marble, we realize that while the machines are dead, the biological ripple we caused is still spreading. We are moving toward the final chapters of our thought experiment. The era of the genetic echo is next, where we will look for humanity not in stone or metal, but in the DNA of the life that survives us. We have looked for humanity in the sky, in the rock, and in the atom. But perhaps the most profound library of our existence is not written in dead matter. It is written in the living code of the planet. We were the first species to reach into the engine room of evolution and tinker with the gears. We domesticated plants, bred animals, and spliced genes. We rewrote the biology of Earth to suit our needs. And even 10,000 years after we are gone, that rewritten code will still be replicating generation after generation. The most tragic legacy we leave behind is in our crops. Consider corn, maize. It is the most successful plant on Earth by biomass, covering millions of acres. But it is a biological monster. We bred it from a wild grass called teosinte, selecting for larger and larger kernels until it became the cob we know today. But in doing so, we trapped the seeds inside a thick, leafy husk. Corn cannot reproduce without human hands to peel the husk and scatter the seeds. In the first few years after the silence, millions of acres of corn stood tall in the fields, waiting for a harvest that never came. The cobs grew heavy. They fell to the ground, but the husks held. The seeds sprouted inside the wet darkness of the rotting husk, choking each other in a desperate competition for light and nutrients. They died in a tangled, rotting mass. Within 3 or 4 years, corn, the king of crops, was extinct. It is a species that exists only as a partner to humanity. When the partner vanishes, the crop follows. But other plants are not so helpless. Wheat, rice, and soy have wild cousins. In the 1st century, the manicured fields of our agriculture became battlegrounds. The domesticated crops interbred with the wild weeds surrounding the fields. Pollen drifted on the wind. The genes we selected, genes for large seeds, rapid growth, or drought tolerance, flowed out of the farm and into the wild. 10,000 years later, a botanist studying the grasslands of North America or the steppes of Ukraine would find something strange. The wild grasses would carry genetic sequences that do not belong there. They might find a gene ghost, a sequence of DNA that codes for resistance to a herbicide that hasn't been sprayed for 100 centuries. These genes are useless now, floating junk in the genome, but they are a signature. They say, someone modified this plant. This is even more true for genetically modified organisms, GMOs. We splice genes from jellyfish into fish to make them glow. We put genes from bacteria into soy. We created organisms that crossed the boundaries of the kingdoms of life. In the wild, glowfish, those neon tetras sold in pet stores, would likely be eaten quickly, their bright colors making them easy targets for predators. But the gene for bioluminescence might jump. Horizontal gene transfer is a rare but real phenomenon where bacteria move DNA between species. It is possible, in the deep future, that we might find a species of wild carp in a river that carries a fragmented, inactive copy of a jellyfish gene, a remnant of a pet store escapee from the Holocene. It would be a biological anomaly, a puzzle for future science. Then there are the fruit trees. An apple tree grown from a seed does not produce the same apple as the parent. It produces a wild apple, often small and bitter. The sweet apples we eat are clones, propagated by grafting. When we disappear, the orchards will go wild. The trees will die, but their seeds will sprout by the year 10,000. The forests of Central Asia, Europe, and America will be dotted with wild apple, pear, and cherry trees. They will not be the grocery store varieties. They will be tough, thorny, and bitter, but their genetic diversity will be off the charts. They will carry the chaotic mixture of all the varieties we planted. A forest in Ohio might harbor a diversity of apple genes that would otherwise exist only in a laboratory. We have effectively terraformed the biosphere with our food. The animal kingdom tells a similar story. We spoke earlier of the generic dog, the wolf-like survivor of the suburbs, but these animals will carry the ghosts of their ancestors. Even 10,000 years later, you might see a pack of wild predators on the ruins of Paris where one individual has floppy ears or a spotted coat, traits that are disadvantageous in the wild but linger as recessive echoes of the golden retriever or the Dalmatian. Cows and sheep, largely doomed, might survive in isolated pockets, perhaps on islands where there are no predators. On a remote island in the Pacific or the North Atlantic, a future explorer might find a population of feral cattle, small and aggressive, but unmistakably bovine. They would be a landrace, a domestic animal returned to the wild, shaped by natural selection but built on a domestic frame. And then there is the human body itself. We are 8 billion people. We are the most numerous large mammal on Earth. When we die, we usually bury our dead in boxes, deep in the ground, often embalmed. This is a recipe for fossilization. In 10,000 years, the cemeteries of the world will be geological features. The human layer we discussed in the context of technofossils is also a bone layer. A future paleontologist digging into the strata of the 21st century will find a global mass grave. But it is an orderly one. Skeletons laid out in rows, all facing the same way, often with metal replacements in their hips or knees, and teeth filled with gold or ceramic. This is the dental signature. Teeth are the hardest part of the body. Modern dentistry creates teeth that are unnatural. We drill holes and fill them with composite materials. We screw titanium posts into jawbones. These artifacts do not decay. In the year 10,000, even if the bones have turned to dust, the teeth and the implants will remain. A handful of titanium screws and a scattering of ceramic crowns will mark the resting place of a human being. Our bodies also leave a chemical shadow. We take medicines, antibiotics, antidepressants, painkillers. These chemicals pass through us and into the water treatment plants, and from there into the river sediments. We are discovering that pharmaceutical residues can persist in the environment for a long time. The opioid layer or the antibiotic layer in the sediment near major cities might be a detectable chemical anomaly, a thin stripe of complex molecules that marks the era of modern medicine. Finally, there is the microbiome. We carry billions of bacteria in our guts that are specific to humans. When we vanished, those bacteria entered the soil. Most died, unable to compete with soil microbes, but some might have swapped genes with the locals. The soil bacteria of the year 10,000 might carry resistance genes to our antibiotics, or enzymes adapted to digest our processed food. We have inoculated the dirt of the planet with the biology of our bodies. The genetic echo is subtle. It is not a monument you can see from space, but for anyone who knows how to read the code of life, it is everywhere. The trees, the weeds, the wild dogs, and the soil itself are all vibrating with the information we injected into the system. We have become part of the evolution of the planet, not just as observers, but as editors. And the edits remain even after the editor has left the desk. We have arrived. The clock has ticked forward 10,000 times around the sun. The journey from the silence of the first day to the deep geology of the 10th millennium is complete. Now let us stand on a high point, perhaps the rim of an ancient volcano or the top of a mountain formed from the rubble of a city, and look at the world. The first thing you notice is the green. The earth is verdant. The climate is warmer than the one we knew. The ice sheets are smaller, the sea levels are higher, and the tropical zones have expanded. The carbon pulse we released in the industrial age acted as a superinterglacial event. We delayed the next ice age. By all orbital mechanics, the Milankovitch cycles, the Earth should be cooling down, but our blanket of CO2 has kept it warm. This is perhaps our longest-lasting legacy. We stopped the ice. The coastlines are different. Florida is a jagged archipelago of limestone islands. The Netherlands is a shallow sea. The great deltas of the Nile, the Ganges, and the Mississippi are submerged estuaries teeming with marine life. The cities that stood there are gone, buried under 50 meters of silt and water, preserved as time capsules for a future that may never find them in the interior of the continents. The new wilderness is mature. The forests are tall and thick. But if you look closely, the geography is strange. The land is bumpy. There are unnatural ridges and mounds hidden beneath the trees. These are the tell formations of the Anthropocene, the collapsed ruins of our sprawling suburbs and industrial parks, covered in soil that a river might flow suspiciously straight for 10 miles, a memory of a concrete channel that forced it into a line. A hill might have a perfectly flat top, a memory of a leveled construction site. The landscape is a palimpsest, a manuscript that has been scraped clean and written over, but the old words still show through as faint indentations that if you were to walk through the forest that was once Manhattan, you would be walking on a ridge of hills. The skyscrapers have fallen and turned into piles of rubble. The soil on top of them is thin, supporting mostly grasses and shrubs. The valleys between the hills, the old streets, are thick with trees growing in the deep, sediment-rich soil. The city has become a negative of itself. The streets are forests, and the buildings are rocky outcrops. Occasionally, you might find a hard artifact, a piece of stainless steel, perhaps a kitchen sink or a car bumper, glinting in the sun, freed from the soil by the roots of a falling tree. It is untarnished, bright, and alien. A ceramic toilet bowl, white and perfect, sits in a stream bed. A diamond ring, washed out of a grave, lies in the gravel. These are the sparks of the past, tiny anomalies in a natural world. The atmosphere is clean. The smog, the particulates, the industrial haze, all gone. The sky is a deep, piercing blue. At night, the Milky Way is a solid band of light, unpolluted by electricity. But if you have a telescope and you look at the equator, you might see that faint, glittering ring of space debris, the halo of the dead machines. The silence is the most profound change. The background hum of the Holocene, the engines, the tires, the sirens, the HVAC systems is gone. The soundscape is purely biological and meteorological. Wind, thunder, bird calls, insect drones. It is the sound of the earth as it was for millions of years before us, and as it will be for millions of years after. But a trained eye would see that this is a post-human world. The biodiversity is lower than it was before humans. The megafauna, the mammoths, the rhinos, the great apes are mostly gone unless they survived in our era, which they largely didn't. The world is populated by the survivors. The rats turned grazers, the pigs turned predators, the deer, the raccoons, the crows. It is a weedy world, a resilient world, rebuilt from the scraps of the extinction event we caused. And deep underground, the golden spike is set. The layer of plastic, radioactive dust, and chemical pollutants is hardening into rock. This is our signature. Even if every building erodes, even if every book rots, this layer will circle the globe. It is a geological fact. It says, something happened here. It was fast, it was energy dense, and it changed the chemistry of the planet. To an alien archaeologist arriving now, the human era would look like a fever. A sudden explosion of carbon and temperature, a mass extinction, a layer of weird artifacts, and then silence. They might wonder if we burned ourselves out or if we left for the stars. They might dig up the moon and find the answer. Or they might simply catalog us as one of the Earth's many moods. A brief, fiery temper tantrum that reshaped the furniture before the planet went back to sleep. This vista is not sad. It is peaceful. The Earth has healed. Carries scars, yes, but scars are just the way history is written on the skin of a planet. We are part of that history now. We are the scar, and we are the soil. We have one final step to take. We must step back from the visual and ask the ultimate question of meaning. In the conclusion, we will weave all these threads, the domestic, the industrial, the cosmic, and the biological, into a final thought on what it means to be temporary. We have walked through the valley of silence. We have watched the fires burn out, the roofs collapse, the waters rise, and the forests return. We have seen our machines turn to rust and our plastic turn to rock. Now, at the end of our journey, 10,000 years from the moment the lights went out, we must answer the question we started with: what remains? To answer this, we must understand the difference between being gone and being forgotten. Humanity is gone. The noise of our civilization, the radio waves, the traffic, the arguments, the music, has dissipated into the vacuum of space. But we are not forgotten. The Earth does not forget. It remembers, but it remembers in its own language. The language of the Earth is geology. It is a language of layers, pressure, and chemistry. In this language, humanity is not a collection of individuals or nations. We are not defined by our art or our wars. We are defined as an event. In the deep geological record, there are other events. The Great Oxidation Event, 2.4 billion years ago, when bacteria filled the air with oxygen and rusted the oceans. the end Permian extinction, when volcanoes in Siberia burned for thousands of years and almost killed the planet. The KPG event, when an asteroid slammed into the Yucatan and ended the reign of the dinosaurs. We are the next event. We are the Anthropocene event. 10,000 years from now, we are a distinct, sharp, undeniable layer in the crust of the planet. We are a stripe of radioactive isotopes, heavy metals, microplastics, and homogenized biodiversity. We are a fever that spiked for a few centuries and then broke. This perspective is humbling, but it is also clarifying. It tells us that our legacy is not what we thought it was. We spent our time building monuments to our vanity. Skyscrapers, statues, tombs. We wanted to be remembered for our greatness. But the earth remembers us for our impact. The pyramids might stand, and the footprints on the moon might remain. But the true monument to humanity is the altered chemistry of the atmosphere and the ocean. This realization brings us to the concept of the technosphere. For a brief moment in geological time, the Earth grew a new system. Alongside the lithosphere, rock, the hydrosphere, water, and the biosphere life, there was the technosphere, a global layer of processed materials, energy grids, and information flows. It weighed 30 trillion tons. It was massive, complex, and hungry. In the year 10,000, the technosphere has collapsed into the lithosphere. It has become rock, but it has left a permanent scar. The future Earth is a used planet. It has been processed. Its resources have been rearranged. Its biology has been remixed. It is not a ruined planet. Life is flourishing, green, and vibrant, but it is a changed planet. We pushed the Earth into a new state, and it will never go back to the way it was before us. Is this a tragedy? From the perspective of a human lifespan, perhaps. The loss of our culture, our knowledge, our songs. That is a heavy sorrow. But from the perspective of the planet, it is just another Tuesday. The Earth is 4.5 billion years old. It has seen global ice ages, supervolcanoes, and asteroid impacts. It has been a ball of magma and a snowball of ice. It has been covered in giant mushrooms and giant reptiles. We are just the latest chapter. We are the species that learned to use fire, burned everything we could find, changed the sky, and then vanished. In doing so, we cleared the stage for whatever comes next. Perhaps the biodiversity that springs from our weedy world will be more resilient. Perhaps the intelligence that rises next, if it ever does, will find our technofossils and learn the lesson we failed to grasp. That infinite growth on a finite planet is impossible. The memory of the planet is patient. It stores our plastic in the rock as a warning. It stores our carbon in the air as a climate legacy. It stores our nuclear waste in the deep dark as a curse. But it also stores the beauty of what we were. The pollen of the flowers we planted is in the mud. The bones of the dogs we loved are in the soil. The atoms of our bodies are now part of the trees and the deer and the birds. We are not separate from the earth. We never were. We emerged from it, we shaped it, and in the end, we returned to it. The silence of the year 10,000 is not an empty silence. It is the silence of a library after the patrons have left. The books are still there, written in stone, waiting for someone to learn how to read them. And so we return to the present. We return to the room where you are sitting, to the hum of the computer, to the light of the screen. We return to the noise of the now. It is strange, isn't it, to look at your hand, at the walls around you, at the city outside your window, and know that it is all temporary. To know that the concrete is just sand waiting to be released, that the plastic is just rock waiting to be formed, that the silence is waiting patiently beneath the noise. This thought experiment, this journey into the deep future, is not meant to scare you. It is not meant to make you feel small or insignificant. It is meant to make you feel present. Fragility gives value. If a flower bloomed forever, we would not marvel at it. It is because the bloom is brief that it is beautiful. Our civilization, our lives, our moment in the sun, it is all incredibly fragile. We are a candle flame in a hurricane. The fact that we are here at all, that we can think and feel and build and wonder, is a miracle of probability. We are the eyes of the universe. For a brief flash of time, the atoms of the earth have woken up and looked at themselves. We have told stories. We have loved. We have tried to understand. Even if we vanish tomorrow, even if in 10,000 years the only trace of us is a thin layer of strange rock, that does not erase the fact that we were here. The experience of being human, the taste of an apple, the warmth of the sun, the sound of laughter is real. It happened. And in the quantum fabric of the universe, what happens cannot be unhappened. The moment exists forever, even if the memory fades. So when you look at the world tomorrow, look at it with the eyes of a traveler from the year 10,000. Look at the skyscrapers not as permanent monuments, but as temporary sculptures of glass and steel. Look at the road not as a fixed line, but as a future forest clearing. Look at the plastic bottle in your hand not as trash, but as a future fossil. And most of all, look at the people around you. They are the only people who will ever know this version of the world. They are your fellow travelers on this brief, bright spark of consciousness. Be kind to them. Be kind to the earth. We are the caretakers of this moment. We are the authors of the layer we are leaving behind. Let us try to write a story that, even if it cannot be read, was written with care. The silence is coming, yes. The entropy is winning, yes. But right now, the music is playing. The lights are on. The story is happening, and you are part of it. Thank you for joining me on this long journey into the deep future. It is a heavy topic, I know, but sometimes we need to look far ahead to understand where we stand right now. If you enjoyed this drift through time, if you found some calm in the catastrophe, I would be very grateful if you gave the video a like. It helps this little channel survive in the algorithm, which is, in its own way, a struggle against entropy. And if you want to join us for more mysteries, more histories, and more journeys into the dark and the deep, please subscribe. We have many more layers to uncover together. For now, sleep well. The world will still be here when you wake up, and that is a beautiful thing. Good night.